Okay, so this is lesson 5.6, exponential equations. Zoom in on that. So we're going to solve for logarithmic equations and exponential equations. Okay. An example of solving a logarithmic equation is where we have a log, and we have x plus 6 to the base 5 plus log x plus 2 base 5 equal 1. So this is an example of a logarithmic equation. Well, we can't solve it in this form. What we have to do is we have to go through what we call logarithmic condensing. We got to condense it. So the domain is basically we take what's inside and we solve for it. So x plus 6, we take that, x plus 6 equals 0. And then we solve for x, and so we're saying that x equals to a negative 6. Well, what that means is that any solution cannot be x is either greater than or equal to negative 6. So graphically, at negative 6, the graph is going to look something like this. So anything more negative than negative 6 is undefined. It's outside of this curve. So we use that to help us solve logarithmic equations, in that anything less than that, anything outside of the domain is not a solution. Okay, so let's take a look at some properties of logarithms. We said once before that we have an equation in logarithmic form, such as log x base a equals to y, and we want to convert that to exponential form. Then you start with the base of your logarithm is the same as the base for your exponent. So your base, this is log x base a equal y. So a is the base of your logarithm. So a is going to be the base for your exponent. And then you take the x and y and you switch. So now the y is on the a side and the x is on the other side of the equal sign to our base. Okay, let me get the lights here real quick because there's glare there. Okay, so that's one way to solve for a logarithmic equation. And you can also go back the other way. If your equation is an exponential form and your unknown is up there as an exponent, you can convert it to a logarithmic equation. So you can go back one way or the other. And in mathematics, that's what we're talking about when we say if and only if. So in other words, we can say log x base a equal y if and only if a to the y equals x. So if and only if means it works one way and then back the other way too. So in other words, a to the y equals x is also equal to log x base a equal y. So that's what we mean in mathematics when we say if and only if. If and only if. Okay? All right, now another thing that we said before with properties of exponents is we said that if a to the u equals to a to the v power, then if the bases are the same, then we can set the exponents equal to each other. Okay? That was a property of exponents that we did. Next, now what we're saying in the property of logarithms is that if log m base a equals to log n base a. So now we're saying that if the bases to our logarithms are the same, and we have two logarithmic equations on either side, and the bases are the same, then we can say, all right, m equals n. Okay? So in other words, if we have an equation such as log, let's say 5 base 2 equals to log x base 2, then we can say, all right, since these bases are the same, then we can say we can say that these two, we can set these two equal to each other. Okay? Questions with that?
No, sir.
All right, so let's take a look at a problem. And so we're going to, I'm going to leave this board that's on the board here and use a different one. All right, we're saying here in this next problem, better if I just write it, solve log 4 base 3 equals to 2 log x base 3. All right, so with properties of logarithms, we can take this 2 and we can move it up to an exponent. So this would be log 4 base 3 equals to log x squared base 3. So the base for one side is the same as the base for the other side. So therefore we can say, all right, 4, so we can set these two equal to each other. 4 equals 2x squared. And then we solve for x. So we apply the square root, plus or minus, and we get x equals to plus or minus a negative plus or minus 2. So we're saying that x equal to 2 and x equal to a negative 2. But we have to go back and check it. So we have to go all the way back to the original equation to check it. And with logarithms, you absolutely have to check it, because some of the times, not every time will all the equations, all the solutions work out. Sometimes only one of the solution works out, and sometimes neither solution works out. And so you have to check it. So we go back to check it by substituting each value in there. So log 4 base 3 should equal to 2 log, and then we substitute in. So we're going to substitute in a -2 first. Well, with the properties of logarithms, log of a negative anything, I've got -1, but it could be any number, where a is any number, is undefined, because it's outside of the domain. So you can't have a negative logarithm in the original function. So therefore, -2 is no good. So let's try +2. Let's try +2. So we've got here log 4 base 3 equals to 2 log +2 base 3. So we're okay so far because it's not negative. So now we can move that 2 up, and we've got log 4 base 3 equals to log 2 squared base 3. Well, 2 squared is 4. So log 4 base 3 is equal to log 4 base 3, so it checks. So x equal 2 is a good solution, but x equal -2 is not. Okay? Questions with that?
Could you go back down real quick?
This way?
To the -2? Yes, sir.
Oh, the -2? Okay.
Wait, not -2, but +2.
Did you have a question?
Does that 2 have an exponent? Does that 2 have an
Um,
exponent?
this 2 can be moved up.
No, I'm talking about on at the bottom
Oh,
where you put a check
here?
mark. Yes, sir.
Yeah, because you move this 2 up. Because first you check to see, can I use this before I move that exponent up? If this is negative, if you have a log of a negative number, then you can't use it because it's undefined.
Uh-huh.
So you check to see, can I even use this first? Yeah, 2's good. It's not a negative number. So now you can move the exponent, the 2 up as an exponent. Okay, and you get log 2 to the second base 3. So 2 squared is 4, right? So we're saying log 4 base 3 equal to log 4 base 3. Okay, does that help?
Yes, sir.
Okay, good. All right, any other questions?
No, sir.
All righty. Okay, so before we go any further, let's go through some properties of logarithms. Okay, we said before that log of a negative number is undefined. Okay, also log a to the r base a. If the base to your logarithm is the same as the base to your exponent, then the answer is the exponent. Okay, so if we had log 2 to the 5th base 2, the answer would be your exponent. Okay? All right.
Yes, sir.
Um, so if you have log m times n base a, sometimes you can either expand or condense logarithms to solve for them. So when you're multiplying two terms like this could be 2x, right? Then this would be log m base a plus log n base a. So when they're multiplying, you expand it out, you're adding it. Okay, and their bases stay the same. Log m over n base a. Now you have log m base a minus log n base a. So if they're dividing, whatever's in the denominator, you're going to subtract it. Okay, so now if you have a log, let's say b to the c power base a, and you want to expand that, what you can do here, because this is up here as an exponent, it's not multiplying like this one is. You can move that down and multiply c times log b base a. And that's what we did in the last problem. Okay? All right. Any questions there?
Could you slide up for me a little bit?
Oh, sure. Here?
Yes, sir.
And I'm going to go ahead and let's draw some lines here.
Okay, I got everything.
Okay. So I'm going to also put these other properties on here. Converting log x base a equal y. Change it to exponential, a to the y equal x. Okay, we talked about that one. And we talked about if a to the u equal a to the v, then u equals v. And we also talked about if log m base a equal log n base a, then m equals n. Okay, so I'm just going to write those on this one so I can use this other. All right, so let's take a look at another problem. And here we have.
I didn't see the last one. The last one you wrote.
What's that?
So I didn't see the last one you wrote.
Oh, you mean up here? All I did was I rewrote what I wrote in the other one.
Oh, okay.
Yeah, because that way I've got them all on one board.
Okay.
Instead of two boards. Okay, we want to solve log x plus 2 plus log 1 minus x equal to 1. Okay, let me get the door real quick because it's kind of noisy out there in the hall. Okay, before we start, we want to find the domain. Okay, so we take what's inside the parentheses, x plus 2, and set it to greater than or equal to 0. So if we subtract 2 to both sides, we get x must be greater than or equal to negative 2. And we do the same thing with this one. 1 minus x greater than or equal to 0. And so we subtract 1, right? We get negative x is greater than or equal to 0, greater than or equal to negative 1. And we divide by negative 1 to get rid of that negative. We got to flip that inequality sign. So x is less than or equal to negative 1. So therefore, x has to be greater than or equal to negative 2, but less than or equal to negative 1. Okay, so it can't be, so it has to be greater than negative 2, but less than negative 1. So all right, so let's erase that. So in our solution, as long as we don't get a negative inside, we're okay. So what we have to do now is condense this. So basically, what we're doing is this one here. So log mn equals to log m plus log n. So this is where we're at right now. So we have to go back the other way and condense it and multiply. So we're saying log m plus log n is equal to log m times n. And this is all base 2. This is a base 2 and this is a base 2. Okay, so we're going to condense this. We're going to take these two and condense it to a single logarithm. So this will be x log base 2 x plus 2 times 1 minus x equal to 1. Okay? Questions with that? So all we did is we just took these two and condensed it to a single logarithm.
So don't do the thing you did first when you did the domain.
No, that we can check it without having to figure out the domain.
All right.
So from here, we can use converting this from logarithmic form to exponential form. So like we said before, with here, we can convert it from logarithmic form to exponential form. So we look at the base of our logarithm and we put that first, and then we switch the two other parts. So I'm just going to rewrite this log x base a equal y equals to a to the y equals x. All right. So we start with the base of our logarithm is the same as the base for our exponent. Okay. And then we switch these two, like what we did here. So the exponent is going to be the 1, and then the other side of the equal sign, the x plus 2 and 1 minus x go on the other side of the equal sign. Okay, so we took these two parts and we switched. We looked at our base for our logarithm first, and then we took these two parts and switched them. So now the unknown variable is outside of the logarithm, and we can solve for that. Okay, so this is just going to be 2 equals 2x plus 2 times 1 minus x.
I can't see.
What?
I can't see it. Okay, there you go.
Okay, so now we FOIL it and solve it as a quadratic equation. So 2 first terms, so this will be 2 equal, 2 first terms will be x times 1 is 1x. X times a negative x is a negative x squared. And then 2 times 1, that's plus 2. And 2 times negative x is a negative 2x. Questions with that?
No, sir.
Okay, so now we bring that 2 down and we combine like terms. So we'll put the negative x squared first. X minus 2x is a negative 1x plus 2. Okay, questions with that? Well, in any quadratic equation, we've got to set it equal to 0. Now, I always like to try to keep the x squareds positive. So I'm going to add the x squareds. You could subtract 2. Well, let's do that. Let's do it. Let's do that. We'll just subtract 2 minus 2. Okay? And we get 0 equals to negative x squared minus x. You got a positive 2 and a negative 2. The 2's go to 0. Okay? So whenever you're solving for a quadratic equation, you always got to set it equal to 0. Right? So that's why we had to move that 2 over. So we could set it equal to 0 and use the 0 factor property, right, to solve. Well, now we want to solve for x squared, negative x squared minus x. Well, we can factor out a common factor here. Common factor here is a negative, and what other common factor is there? You got x squared and x, right? So you have a common factor of a negative x. So that leaves you with, factor an x out of x squared, that leaves you with x. But because you factored out a negative, that makes that a plus. And then factor x out of x is just a 1. So just like when you distribute a negative in, you change all the signs, right? Like if you had negative 1 times x plus 2, and you distribute negative 1, you get negative x minus 2, right? When you distribute a negative, well, when you factor a negative out, you also change the signs. Okay, so now we can set each factor equal to 0. So negative x equals 0 and x plus 1 equals 0. Subtract 1, x equal to a negative 1. Okay, so we've got, and then here we can divide negative 1, right, to both sides. Well, 0 divided by negative 1 is still 0. So x equals 0 and x equal negative 1, but we still have to check it. So we can check it, an easy way, we can check it by substituting it back into the original equation. And as long as we don't get a negative inside the parentheses, we're good. So we're going to put in here, we're going to start with x equals 0. So this will be to check it, log base 2, and so we put 0 plus 2 plus log 1 minus 0 base 2 equal 1. So all I did was I took this solution and plugged it back into the original equation, okay? And so 0 plus 2 is 0, so we're good there. And 1 minus 0, that's just 1, so we're good there. So x equals 0, that checks. That's a good solution. So now we're going to do the same thing with -1. So now instead of, we're going to put -1 in here for x and -1 in here for x. So we put -1 in here, and we put -1 in, oops, no, it's the other way. But it's minus a -1, because this negative is for the logarithm, for the original equation. So we're going to put 1 minus a -1. So this negative is for the original equation, and this negative is for the solution. So you got to put minus a negative. Well, 1 minus -1 plus 2, that's just 1, so that checks. And minus a -1, the opposite of 1 minus 1 is 1 plus 1, and so that's 2, and that checks, so that's not a negative either. So both of these solutions check. So we got 2 solutions this time, okay? And so that's how we do that problem. Questions there? Okay. Let's look at the next problem. Okay, we said, so here we have solve. We've got 3 to the x equals to 7. All right, so we can use, because we said before that if a to the u equals a to the v, then u equals v, right? We can set these two. But you can only do that if these bases are the same. If they're not the same, then you can't use this, because you have a base that's a 3 and the other base is a 7. So you can't set these exponents equal to each other. So what we can do instead is use the property of logarithms right here. So what we're doing in this case is we're working backwards. We're saying if m equals n, and we have an unknown up in the exponent, then what we can do is we can apply log to both sides and then bring that exponent down. So from here, we're saying, okay, the problem is we've got this unknown up here as an exponent. And so we can't solve this problem as long as that exponent, as long as that x is up there as an exponent. So we've got to bring that down somehow. So the way we do that is we use logarithms. So we can either apply log or natural log to both sides. So in this particular example, they use natural log. Well, what's natural log? Natural log is nothing more than log x base e, where e is roughly is a number. It's 2.7 rounded off. Most people use 2.71. I like to just use 2.7. To me, that's just as good. So log e is a number. So this is really just, natural log is nothing more than just log base 2.7, okay? All right, so we apply natural log to both sides. And when we do that, then we can apply this property here where we can bring that exponent down. And so when we bring that x down, now we can solve. Okay, so now we have x natural log 3 equals to natural log 7. Okay, now from here we can solve for x. Now what I like to do is I like to go ahead and find what this is first. I'm going to show you the way I do it, and then I'll show you how the textbooks generally show you. But I don't necessarily like doing it that way because students can make an error. It's easy to make an error that, in my mind, it's easy to make an error in that way. So now on my cell phone, okay, I've got my TI-84 app. Do you have your TI-84? If you don't have your app on your cell phone, you can go ahead and put it on your cell phone. All right.
I got it.
Okay, good. So we go to so what I do here is I put in the natural log first. Okay, so we go to natural log, and it comes up there, and you put in 7. Okay, and you hit enter, and we get 1. Now this is rounded off to 4 decimal places because I've got it rounded off. No, hold on a minute. You go to mode, decimal. I've got it rounded off, so I'm just going to go back to the other way. All right, clear that. Okay, so now here we've got our answer not rounded off. I mean, it rounds off to like, I think it's like 19 decimal places. I'm not going to count them, but so we're going to write this as x natural log 3 equals to 1.9459 dot 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 dot, and it goes on. Okay, we don't need to write the whole thing. Now we can continue to solve by dividing. We want to isolate that x, so we divide by natural log 3 to both sides. Natural log, divide by natural log 3, divide by natural log 3. So we take this number and we don't clear it, leave it on there, and we hit divided by, and it'll say answer, and that'll give you the last answer you had. And then natural log, so we're dividing natural log 3. And I always like to close the parentheses on there. And hit enter, and we get 1.7712 and so on. So x is the squiggly looking equal sign means approximately equal to 1.7712, and it goes on. So they rounded off to 1.771. Okay. All right. So the textbook, what they do is they just go ahead and divide x natural log 3 equals to natural log 7. Divide by natural log 3, and you get x equal to, and then you can divide. Well, the problem with this is if you don't close this parentheses here, you'll get an error. So, and a lot of students don't do that. So that's why I go ahead and figure out what natural log 7 is first, and that eliminates that error. And that way you can divide natural log 3. Now this, natural log 7 over natural log 3, this is an exact answer. Okay, this is an exact answer. If they ever ask for an exact answer, then that's what you write. But 1.771, that's approximate, that's rounded off. All right, logarithms are irrational, most of them. I mean, unless you get something like log 2 base, where the bases are the same, then whatever you have here, that's not irrational. All right, that's a rational number. But most solutions for logarithms are going to be irrational. Okay? Questions there? All right. Let me just look at something here real quick. Okay. All right. Let's go to something that's on the homework. All right. Let's say we have this. All right. We're almost out of time, but here's one. E to the 3x equals to 5. Okay, these two bases are not the same, so you can't set the exponents equal to each other. So we have to use logarithms, right? So we can apply natural log and natural log. So we can say, all right, natural log e to the 3x equals to natural log 5. We can apply natural log to both sides, okay? Well, natural log is log base e, right? Natural log is log base e. So what we're saying here is that this is log e to the 3x base e equals natural log 5. Well, here, base of our to our logarithm is the same as the base to our exponent. So that means that these two cancel each other out. And so we just get 3x equals to natural log 5. Okay? And so now from here, we can find what natural log 5 is. And so natural log 5, oops, clear that. Natural log 5, close that. We get 1.609 and so on, right? 1.60943, and it goes on, right?
Sir?
Equal to 3x. Well, now we can just divide 3x, right? I mean, divide by 3. Divide by 3. And so we just keep this in the calculator, and we just divide that by 3. And we get 0.536. X equal to 0.536. Well, you can check that by plugging it back in here, and you should get 5, right? So the way you can check that is you can put in here, here's e to the x, right, up here. So hit second and e to the x, and clear that. Second, e to the x, and put 3, and then second, an answer. And that produces the last answer you had, which is this, okay? And then hit equals. Okay, let's just round that to 0.536. Let's try again. Second E, and then 3 times 0.536. And you get, because we rounded this off, you get 4.99. It's not exactly 5, but it's close enough to tell us that we got the right answer, okay? If you move this out to like 7 decimal, 5 or 6 decimal places, you get closer to 5, all right? So this is a good answer here.